Hello and welcome again. This time we have lecture number 6. We start with a quick recap of what was previously. So last time we had a talk by Rolf Smets about user interface and user experience, and the previous time I was telling about components and their properties. Today we are somewhat merging both of these two lectures, so I will talk about managing the look of your web application and something about the navigation between different views in your app. So these are, along with the all previous lectures, this should be enough to get you going on the very first, very simple applications. This is what we are going to talk about today. So something about Subwindows, ways to not show notifications to the user. Then we go to layouts, then something about themes, which is the CSS and styles of the application, then something about the navigator, and finally, time permitting, there will be some demo. So let's start with Subwindows. You might remember that from desktop applications. This is a distinctive feature of desktop applications, that there is a huge number of windows that belong to an app. Web applications tend not to have that, as everything is displayed in the browser. Most of the windows that appear are usually some annoying pop-ups, which is one of the reasons we tend to avoid that. But sometimes you just might want to have an application that looks like a desktop application and run it inside a web browser. This can be, for example, for compatibility reasons, compatibility of user experience. So you have a typical desktop application which you are porting to a web interface. So not to put any obstacles in front of the user, then you just port also the UI with windows and things like that. So what is a window? It's basically a floating panel within a browser window. It cannot exist outside the web browser window, so it's bound to whatever the user sees there. It is a single component container. In fact, this is a panel, a subclass of a panel class I was presenting last time. So it has all the features of a panel, meaning a scroll bar appearing magically and ability to set caption and icon and things like that. What is different is that it has a dedicated method to attach it to the user interface. So it's not add component as you would do with any other component, but it's add window. And adding window through a regular add component method will cause you a runtime exception. These are the 4 basic properties of a sub window, which are very handy. Of course, each window is sizable, meaning that it has a width and height, although there is no support for minimizing and maximizing the window. So if you want that features, you have to implement that yourself. It's a little extra effort, but it's surely doable. And you can of course set the size programmatically according to your preferences or user input. Windows or sub-windows are also movable. Again, moving is restricted to the browser window and can be set programmatically, so you can position your window the way you want by calling set position X and set position Y, pixels from left and pixels from top accordingly. Closable is another property, so each sub-window by default is closable, meaning that there is a X in the upper right corner of the window which, when clicked, closes the window. Closing a window broadcasts events which we can catch, so we can, for example, update the database when the user has closed the window. And it can be achieved programmatically by removing the window from the UI or by calling its close method. Finally, each sub-window can be modal. This is again a feature that we have in desktop applications. So an application modal window means that the user cannot switch to any other application window, whereas system modal window is that the user cannot do anything except answering this particular window that has been shown. Of course, since we are running an application inside a web browser which has a sandboxed environment, we cannot have system-wide modal window, but we can have application-wide. If a sub-window is modal, then it prevents other windows from being focused, and it has to be closed or other way dispatched to continue. Of course, you can make many windows modal, only the most recent one will become the one that currently needs to be dispatched. Windows are of course not modal by default, so this is something that you have to set explicitly. An important notice is that this is a browser side feature, so you shouldn't rely in your web application that a window will be actually rendered as modal. Also, a thing to say is that modal windows can be closable, which means that you have a modal window with a, for example, with a dialog message and a button to click it. But then if you have allowed the window to be closable, then there is also an X button, which means that the user can just close the window without doing what you expected the user to do. So you should always double check that your modal windows are not closable unless you really want that. Here on the left is the server-side code, so we create a window with a title or a caption. We set it to modal, we set content to be an image. This is how we attach the window to the current UI. We call a static method getCurrent, and we add window to it. And of course we can style a window to our preferences, so there is a v-window and v-caption and window content inside. So as I said, this is something that perhaps shouldn't be abused in web applications because it brings this feel of desktop applications, but it might add an extra flavor to an application you are developing. Notifications are something that is closely related to Windows and Subwindows, but its purpose is just displaying messages that are hard to ignore. So if you want to communicate something to a user, then you are actually better showing a notification instead of constructing a window and placing contents there. As I said, it's a compact message that should be displayed to a user, and it's displayed as a pop-up, so it shows up in front of everything the user has currently on screen. There are several priorities of each notification. I will tell about them just on the next slide. The trick with the notification is that the message should be compact and it should draw attention. So you shouldn't put too much information there. It should be just, for example, file has been saved, or search returned no results, or there has been some error. Something similar to that. Nothing too detailed. The properties that we have are somewhat similar to what we have with a window. So there is a caption, description, which again shouldn't be too bloated, an icon, position, and in addition to a sub-window we can have a display delay or close and click, which means that the user has to click the notification before the application can continue. Otherwise we have just a delay that causes the notification to fade out automatically. And 4 predefined types, which are as follows. So we have humanized message, which fades away quickly as soon as there is any action on the client side. It should be used for something unimportant because of 2 things. It can be easily ignored. I mean, it just shows up, and if you have been moving a mouse, then you are likely not noticing that message anyway. And the style is very dull by default, so it has hardly noticeable background and colors. The second type of message is warning. So it stays a little even after the user makes some action. It should be used for something that is not critical, but should draw the attention of the user to the message that you are displaying. Finally, we have error message, which must be closed by the user. So this should be used for critical messages. It's very visible by default. It has a red background with white text, and it shows exactly in the middle of the screen. So you just cannot miss that one. And as said, it has to be closed. As an addition, we have also tray notification. So this is something a little different than the previous 3. So it shows in the lower left corner of a window. It's just a notification, so it should not interfere with whatever the user is doing. So how do we show notifications? There are predefined methods for basically almost all the cases that you might want to use. There are static methods in the class notification that make the notification displayed in the current page. As I said, it's suitable in almost all the cases you might want to have it. So method called show, it takes a string as a parameter, and it displays the humanized message or the human-friendly message, which means it disappears really fast. If we add a type, we can specify what type of the message or what type of the notification we want to show. So it can be error box, or it can be warning, or it can be a tray. Finally, an additional string parameter is a description. Of course, you can use custom notifications, meaning that you have to create an instance of a notification, and it requires a page which you might get from either UI getCurrent getPage or page getCurrent. And of course you call show and feed the page there. The drawback is that you have to construct the object and you have to set its properties by yourself. The advantage is that you have full control over how the notification is displayed, so you can set your own delay time, or you can set the colors and styles and everything. This is how we style notification. So there is a vNotification CSS rule. The caption is in header 1 and the description is in a paragraph element. Alright, so these are notifications and windows, and now let's go to layouts, which are the components that don't have any other purpose or functionality other than arranging components. So there is no user interaction at all with these components. They cannot do anything except arranging the components. The three layouts that are listed at the bottom of the slide, they use cell-based rendering, meaning that each component is rendered inside a cell, similar a little to a table element of HTML. Of course, it doesn't use table. Layouts are components, so they have common properties, plus they have some layout specific ones. The horizontal and vertical layouts, they do linear arrangement in horizontal or vertical order. And there is grid layout, which arranges components in a grid and does not allow overlapping components. So if you place a component in a particular cell in a grid, then you cannot put any other component into that cell anymore because it causes a runtime exception. So as I said, there are some layout specific properties common to all three of those. The most important one probably is spacing. If we set spacing of these layouts to true, then we get a component separator, so there will be an empty space between the components. By default, one component is just shown next to another one. There is a CSS rule for that. It's v, then the layout name and spacing on, which allows you to set your custom width or even other styles like images or something like that. And since this is a Boolean property, then you cannot decide the size of the spacing in a code. You have to do it with CSS. Margin, this is another property, is the space around the layout. So this is different than spacing. Spacing is a space between the components, and margin is something that deals with the whole layout. Again, this is a Boolean flag. Although it's possible to set individual margins, you just cannot set the width of a margin. You have to do that with CSS. And amazingly, when you do that with CSS, you should actually use padding property, not margin property. The CSS rules are as follows. So it's a v layout name, margin, and then eventually a side, left, right, top, bottom. Third property is alignment. So as I said, each component is rendered in a cell, and alignment specifies what is a location of a component in its cell. There are 9 values which are presented in this nice table that also shows what they mean. Finally, there is something called expand ratio, which specifies how fast the cells are growing when we are resizing the window. The component size is relative, and the best results is that when the component size is set to 100%, meaning that it will take the entire cell. If we set the component size to an absolute value or to an undefined value, then not the component will expand, but the empty space around the component in the cell. You can combine that with alignment if you want. Okay, and now just to show you how this looks. This is horizontal layouts. They are easy to show. So when by default you construct the layout and add buttons to it or any other components, you see that they are added just one next to another without any space. And if you set spacing, then you have a small gap between them, which makes them look nicer. And then there is margin around that layout, so you see there is more space in the top and bottom and left and right. So here is an example with fixed width, so you can see that the components are actually overlapping each other. When we set expand ratios of all components to 1, that means that each component will take exactly the same amount of space. And this is the expand ratios, so they are set 1, 2, 3 and 4, meaning that the second component should take twice as much space as the first one. This one should take 3 times and this one should 4 times. And again, if you forget to set 100% width, then this is how it will look like. So this is how it looks in the vertical direction. So as constructed, one button is just after another. If you add spacing, of course, there is some space. And now here is an interesting thing to show you how styling of buttons is done. So you should never set the height of a button to be something bigger than actually what the framework thinks it should be, because it causes all the images that are styling the button to appear in a meaningless way. And then the grid layouts, you can span the components in multiple cells. But in general, in the grid layouts, you can have a component spanning over more cells than just one. This is how a typical humanized message looks, and I'm not moving anything, but as soon as I move the cursor, then the message disappears. These 3 are basic layouts, and you can use them in quite big percentage of your applications. However, sometimes you just might want to have a little more control over how your layout looks and how your components are arranged. After all, users pay very big attention to how the application looks. Again, these advanced layouts, they have no functionality and no purpose other than arranging the components, but this time we are not rendering components in cells, we are using CSS or CSS-like syntax. So we have absolute layout, meaning that we have a blank component and we can put components, other components there using a CSS-like string. So we specify the left and right edges of the component and top and bottom. Left means distance from left edge, right means from the right edge, and so on. This component supports overlapping, so if we specify something called z-index, then we can put components one on top of the other. In this component we can also use relative values, so we can use percentage instead of pixels, and this layout displays captions above components by default. For example, in this code on the left we are creating an image. The left edge of the image is 30 pixels from the edge, and then the right edge of the image is 10 pixels from the border of the layout. Whereas for the top and bottom we use percentage values, so when we will be sizing up the component, the spaces will actually increase. Finally, we have a CSS layout. It's a horizontal alignment by default with wrapping, which means that it puts components one next to another, and if it reaches the edge of the screen, then it puts them in another line. And of course, when you resize the window, then the components are wrapped to another line if they need to. This is the fastest layout in terms of rendering because it contains no dynamic logic. Everything has to be styled with CSS. Then again, it supports custom CSS for each component, which makes it rendered as an inline style, meaning that you cannot override it with any other styling. And then the CSS layout is tricky in a sense that it relies on browsers to render the components and position them. And of course all browsers are compatible with the CSS standard, but some of them are more compatible than the others, meaning you should be careful if you use some browser specific settings. This is how it looks. This is an example of how to get a custom CSS for every component. This little piece of code will cause every component to be rendered in a bold font, and it will be impossible to change it. Amazingly, there are CSS rules for a CSS layout, meaning more CSS in a CSS. Finally, we have custom layout, which is a very useful thing because it uses HTML template, meaning that you are actually not having any layout. Instead, you use placeholders in a HTML file. This layout has no CSS because you are using HTML file, which means you can connect CSS to it directly. Okay, themes. Themes, it's a way to reuse how the application looks. Each theme contains styles, which is usually CSS, any resources that can be reused, for example background images or sound files that you want to play when the user enters a page, and all the layout templates that you might want to use. Styles, there can be either CSS or Sass, which is syntactically awesome style sheets if I remember correctly. Other contents we can have in a theme are resources and then templates, and these are all used with the custom layout. So if you are not using custom layout, of course, then you don't include templates in your theme. There are 3 built-in themes: Reindeer, Runo and Chameleon. The last one, Chameleon, is actually a builder for color schemes. It's a little more advanced. Reindeer is a default theme. It contains 3 possibilities: white, blue and black backgrounds. And it's all-inclusive, so it contains all the styles for all the components you can find in the Vaadin core, and it looks good. The Runo theme is a stylish alternative to Reindeer, so it's a little fancier than the default one. So to use a theme, we annotate the UI class with an annotation called theme, and as a parameter we provide a theme name. Then we can add styles to elements. We add formatting rules to the CSS of the theme if we are using our own. And then of course there is a built-in support for built-in themes. Okay, so how do we create a custom theme? There is lots of things that we need to take into consideration. Apart from annotating the UI class, we need to create a CSS file or the Sass file. We need to either import legacy styles or we need to inherit a custom theme. Then we should use constants for style names, so we declare a class and then we declare static final strings as styles and we refer to them. And then the formatting rules in CSS. But there is a simpler way. We can create a theme in Eclipse. So file, new other Vaadin theme, and then we need to select the project. We specify the name and we select the class we add the annotation to. And when we click finish, then the CSS file will be generated, the annotation will be automatically added, and we are then free to modify the CSS file and add our custom styles to components. As of current, there is no support for renaming themes, so if you rename the theme, you have to rename the directories and annotations yourself. Okay, I was talking about CSS for a while, so now the next few slides is a very basic introduction to what are cascading style sheets. So the wiki definition is that CSS is a style sheet language used for describing presentation semantics of a document written in a markup language. So the key part is describing the presentation semantics, which is that this is the language purely devoted to describing how the thing looks, not how it works, but how it looks. That means we can specify all the things related to the presentation part of the web page or of the document. So fonts, colors, images, layouts, borders, backgrounds, everything that is not related to the content but to the presentation. The goal of CSS is to separate styling from contents, support different screen readers, which translates into better accessibility. And as I said previously, since CSS is a standard, it should be cross-browser. Of course, this is just a theory. A basic syntax of a CSS document looks like this. The rules are as follows, most of them at least, or the most important ones. So we can select an element, we can select a class of an element or an ID of an element. Of course, we can combine that so we can have a class and ID. There is a support for parent and child relationship. For neighboring elements, I'm not sure whether these two are nowadays supported in Internet Explorer, but there were problems in the previous versions. We can select any element that has an attribute without checking its value. We can explicitly check for a value, or we can even select a value from a space-separated list. There is a couple of more selectors, but these I think are the most useful ones. Another thing we can have is something called pseudo-class. After we have a selector, we can add a keyword. So probably the most important ones are these two, so hover and focus. Hover means the element under the cursor, and focus means the element that currently accepts input. Properties, which I will talk about in a moment, they accept values, and values can be a numeric value with a unit. The CSS value can have no units. It can be a relative value. It can be text, which has to be quoted. Single or double quotes work. It can be even delay of milliseconds or seconds, and then URLs, colors and angles. How the styling works is it's based basically on the box model, meaning that a content has its own box, then we have a padding box, then there is a border, and there is a margin around that. Must know properties, margin, padding and border. These allow you to specify the box model properties. And there is a number of predefined border styles, so it can be a solid line, a dashed line, a dotted line, a double line. Properties related to color and font, so we can set a color of the main content and the background color. We can set font family, size, weight, which is bold or not, style meaning italic or not, and text decoration meaning underline or not underline. And I think strike through is also a decoration of the text. A note here is that the padding belongs to a background, so if we set the background color to be blue and then we set padding of an element, then the padding will also be blue. Properties related to size, width and height, and floating of the elements. As I said previously, there are selectors during which you specify rules. Then first we take the inline style, which is the style that the element contains. Then we take a more specific rule, which is the one that is more detailed. Some properties can be inherited. The recent rules are usually considered more specific. Then the next one is the style that is included in the document, so it's in the markups style. in the HTML, then is the style that is imported by the document, and then there is any style imported by the style that we are currently using. Alright, enough about styles and layouts. Let's talk a little about navigation. The reason why we want to have a navigation is that actually we are developing a web application, and the users browsing the web, they are used to the fact that we have web pages identified by different addresses. Meaning that when we see something interesting in the internet, we add it to the, for example, favorites, or we want to go back in history to see what page we visited. What Navigator allows us to do is to have that web orientation in our app. We can decompose the user interface into different views, and we can associate a view with a URL address. The user can bookmark it, can share it, it will be stored in the browser history. Navigator is part of the core of Vaadin, but using it, it's entirely optional. What we have is a class that is dedicated to handling the navigation in URLs. It is not a component in itself, so it requires a component that will handle displaying views. So we can either add a view directly, meaning that we have to construct a view first. We can provide a class for a view, and then the class will be instantiated the moment we visit the view. Or we can add the provider of views, which is the factory pattern. So provider allows you to dynamically react to what the user typed, and these one are static, so we have a fixed name for each view. And they are URL based, meaning that this is how it will look. So the hash and the exclamation mark is required, and then we have a view name. So the view is an encapsulation of a single view or a single web page or a part of that web page. Of course, the same view can be available under different names. That's not a problem. The view itself is an interface which we have to implement. When we are building a custom view, we are extending a component. Usually it's a layout, and we are implementing a view interface. So we construct the UI the first time we enter the view. So summary, well, today I have talked about quite a huge number of topics. Hopefully you remembered some of those. So there were windows and notifications, and how do we use them and why do we use them. There were different layouts. I missed just one that I will talk about later. Then there were themes, so how do we use them, how do we use CSS there, and the navigation. Thank you for today. If you have any questions or suggestions, then feel free to bother me with that.